Picture a product manufactured over 100 million times globally. It appears on national flags and revolutionary state emblems everywhere. It is held by state militaries, insurgents, and private security. We are talking about the iconic Avtomat Kalashnikova 1947, known as AK-47. Most people view this weapon purely through Cold War history, but looking at it through business economics reveals something fascinating. This firearm is actually one of the most successful products ever. It solved a massive production puzzle that baffled Western manufacturers. It mastered supply and demand across borders during intense global conflicts. How did a simple stamped metal design conquer the entire planet? To understand this economic miracle, step onto the post-war factory floor. After World War II, military weapons were high-end precision marvels. Take the American M1, Garand, or other heavy wartime rifles. They were meticulously machined from solid blocks of high-grade steel. They featured tight, microscopic tolerances requiring skilled, expensive gunsmiths. Precision engineering makes a great range weapon, but hurts mass production. If a single part breaks, you need specialized armorers immediately. Mikhail Kalashnikov approached this problem with a radically different economic philosophy. His team decided to design specifically for inevitable manufacturing failures. Instead of tight tolerances, they engineered deliberately loose clearance gaps. When dirt or sand enters, the debris pushes aside without jamming. More importantly, production economics changed completely with stamped sheet metal. Instead of milling heavy steel blocks, engineers used heavy presses. This was the exact same technique used to mass-produce automobiles. This clever shift altered the entire financial equation for production. Lower capital expenditure meant you did not need generations of gunsmiths. Instead, the process relied safely on semi-skilled factory labor. Cycle times dropped drastically compared to traditional milling processes. A stamped receiver took seconds, while milled receivers took hours. Material costs plummeted because raw steel waste on the floor decreased. Lowering the manufacturing barrier made production remarkably cheap at scale. Western militaries built high-performance, high-maintenance sports cars for combat. The Soviet Union built the industrial equivalent of a rugged pickup. If low manufacturing costs were the foundation, state distribution was fuel. Standard businesses protect intellectual property aggressively with strict patents and copyrights. They use centralized factories to maximize their corporate profit margins tightly. The Soviet Union did the exact opposite with their strategic design. They pioneered one of the most aggressive decentralized licensing strategies ever. During the Cold War, Moscow handed over blueprints and machinery freely. Factories sprang up rapidly across Warsaw Pact and allied communist nations. Think of this as an open-source franchise model on a global scale. Local governments absorbed all capital costs to build their domestic factories. Production shifted closer to regional conflict zones, cutting shipping costs. The design was continuously iterated to use cheap local raw materials. Without central corporate royalties, production exploded across every single plant. Then came the secondary economic shock of sudden global demilitarization. When the Soviet Union collapsed, its massive military apparatus dissolved overnight. Warehouses held millions of pristine surplus rifles paid for by taxpayers. These facilities were left unguarded or overseen by underpaid, corrupt officials. Suddenly, the global market flooded with cheap second-hand military supply. Basic economics dictates that massive supply drops plummet market prices. In the 1990s, you could buy one for less than a smartphone. Prices sometimes dropped as low as $50 to $100. A product with a 40-year lifespan became infinitely liquid and tradable. It traded almost like a basic global commodity on an open exchange. Every business owner knows sticker price is only half the story. The real financial killer is total cost of ownership over time. This includes maintenance, repairs, specialized labor, and expensive replacement parts. This is where the weapon dominates competitors from an operational standpoint. It requires zero specialized maintenance compared to delicate modern Western rifles. Western rifles need specialized cleaning kits and specific lubricating oils. Neglect a modern precision rifle, and it will fail you immediately. This weapon runs smoothly on whatever oil is available locally. It can even run on cooking oil or dirty diesel fuel. If something breaks, replacement parts are universally interchangeable across variants. Parts built decades apart in completely different countries fit seamlessly together. A firing pin from a Romanian variant drops into a Chinese build. Training overhead is remarkably low because of its extreme simplicity. With minimal recoil management systems and basic iron sights, training takes hours. The labor cost of building an effective fighting force plummeted instantly. In economic terms, it achieved the holy grail of product design. That ultimate achievement was achieving absolute zero operational friction. It required virtually no infrastructure to maintain in harsh environments. No specialized supply chain was required to support its daily operations. No administrative overhead was needed to keep the system running smoothly. For cash-strapped actors in volatile regions, it was the rational choice. These regions often suffered from completely broken local infrastructure networks. Looking back at this economic footprint forces us to rethink product success. It did not win because it was the most accurate weapon available. It did not win because of advanced technology or delicate craftsmanship. It won because it was engineered around brutal real-world human constraints. Manufacturing constraints and tight cost structures dictated every single design choice. It married low-cost, stamped production with an open-source global distribution network. It capitalized brilliantly on massive historical oversupply left behind by superpowers. It completely eliminated operational friction for the end user in the field. This case study offers a stark reminder for any modern industry. Whether selling software, consumer goods, or heavy machinery, rules remain identical. The products that ultimately change the world are rarely the most sophisticated. They are the ones designed with absolute, uncompromising simplicity in mind. They are produced so cheaply that barriers to entry practically disappear. They are distributed so widely that the global market cannot live without them. Let us examine how factory floor scalability drives down unit costs further. When production volume triples, fixed tooling costs spread across more units. This creates an unbeatable economic moat that competitors struggle to cross. Competitors trying to build precision weapons face insurmountable pricing disadvantages from day one. The market naturally gravitates toward the most efficient economic solution available. Simplicity in design acts as a powerful catalyst for rapid market penetration. When barriers drop, adoption rates skyrocket across diverse geographical boundaries seamlessly. This global spread transforms a regional product into an international economic phenomenon. Understanding these underlying market forces changes how we evaluate industrial manufacturing success. It proves that brilliant engineering must align perfectly with economic reality. If a brilliant design costs too much to build, it remains on paper. If maintenance costs are too high, customers abandon the product for alternatives. Longevity in the marketplace requires resilience against economic and logistical shocks. The AK-47 survived political collapse, regime changes, and shifting global alliances intact. Its underlying economic engine kept factories humming, even when borders dissolved entirely. Workers continued production because the demand network remained active and decentralized. Centralized control was never needed to keep the global supply chain moving. Nodes operated independently, adapting quickly to local market conditions and material availability. This decentralized resilience is a masterclass in modern supply chain architecture. Most corporate supply chains fracture under geopolitical tension and regional trade disputes. By contrast, an open-source manufacturing model thrives precisely on localized adaptability and autonomy. Localized production means zero reliance on fragile, long-distance maritime shipping lanes. When ocean freight costs spike, local producers continue operating without missing a beat. This insulation from external macroeconomic shocks protects profit margins across the board. Consumers and end users benefit from uninterrupted availability and predictable, low pricing structures. Predictability breeds deep brand trust and long-term loyalty in competitive markets. Even when alternatives exist, users stick with what they know works under pressure. Reliability under extreme stress is the ultimate competitive advantage in any sector. Think about consumer electronics. Devices that withstand drops and spills dominate sales. Think about software. Simple, bug-free applications often outperform bloated, feature-heavy enterprise suites. The principle remains universal across every imaginable commercial and industrial landscape today. Form must follow function, but function must always respect economic feasibility. Ignoring cost structures leads to brilliant failures that bankrupt ambitious manufacturing startups. Embracing financial constraints sparks creative engineering solutions that conquer global markets. Mikhail Kalashnikov did not set out to create a global economic masterclass. He simply wanted to solve a pressing tactical problem for his nation. Yet by prioritizing mass producibility, he unlocked an unstoppable economic flywheel effect. A flywheel where lower costs drive higher volume, and higher volume lowers costs. Once that flywheel starts spinning, it becomes nearly impossible for competitors to stop. Market dominance follows naturally when economic alignment is executed with absolute precision. As modern entrepreneurs and creators, we can learn profound lessons from this history. Build products that respect the user's operational reality, not just your ideals. Design for manufacturing from day one, rather than trying to fix costs later. Remove every ounce of friction between your customer and your solution. Make maintenance effortless so that total cost of ownership stays remarkably low. Decentralize your approach when scaling globally to adapt rapidly to local conditions. Embrace simplicity over unnecessary complexity whenever you face tough engineering decisions. Remember that the most sophisticated product is rarely the one that wins. The ultimate winner is the one that solves the core problem most efficiently. Economics dictates the lifespan and spread of every single human invention ever created. From ancient tools to modern digital software, market laws apply universally everywhere. The story of this legendary rifle is the ultimate study in applied macroeconomics. It proves that industrial design and market forces are inextricably linked together forever. Next time you analyze a successful global product, look past the surface marketing. Examine the supply chains, the manufacturing tolerances, and the total cost structures. You will likely discover a masterclass in efficiency hiding right in plain sight. That is the hidden economic engine driving the world's most widespread mechanical icon. Master these fundamental economic principles, and you can build products that change history. Thank you for exploring the fascinating economics behind the world's most widespread rifle.